about the chain rule. So again, we need to have a purpose to this, like why. Well, the first question is we can just expand, right? No problem, which is 6x plus 1. And we learned the notation about dy on dx for 18x plus 6. No worries. And the question is, oh, what if it's 5? I mean, theoretically, you can still do it, but it just takes too long because you have to do it 5 times. I mean, even if you do it that way, square and square, that will still take you a long time, right? Just takes too long to do. You can't expand. And furthermore, what if I have a square root? You can't expand a square root. How do I do that? How do I differentiate these ones? All this will be clear by the end of this presentation. So again, necessity is the mother of inventions. Let's look at this question. So to answer this question, we're going to do some investigation. It's the investigation. Let's look at the first part. Y equal to u. Now remember, we learned this notation dy dx. If it's in terms of u, you'll be dy over du. No problem, right? So if it's x, dy dx. If it's u, dy du. Yep. And why is it dy du? Because like you don't have to draw this. So if you draw it, that's the u-axis, that's the y-axis. If you do rise over run thing, it's delta y over delta u, which becomes dy du, if that makes sense, right? So if it's in terms of u, you'll be dy du. Okay. Oh, what if it's y equal to u cubed? Do exactly the same thing. Dy du equal to 3u squared. Or what if it's like that? Well, you do exactly the same thing, and they just get the idea, 15u squared. Hopefully it makes sense. 3 times 5 is 15. Okay, what's the purpose of this? Again, if you be patient, you will see the story unroll. Like just like when you watch a movie, can you fast forward? You just have to be patient, wait. And sometimes you know there's an anticipation. There's something good, something bad, the suspense, blah, blah, blah. You've got to be patient. Just same thing in maths. Okay, let's look at this one. dy over du times du over dx. The du get cancelled, all right? So that means I could, in other words, dy over dx can be written as the product of dy du times du dx. Why is this important? Okay, well, that's very important because that will help us to solve this problem. Okay, so dy du, so the du get cancelled now. But yesterday I just said it is not a fraction, it is a derivative. Yes, it is. But they do, but there's a proof why it get cancelled. But they don't really cancel physically, but you can imagine why where the formula come from. The du somehow cancel, become dy dx. Okay, so now we see this is true, right? Dy dx is same as dy du over du dx. Okay, now this is the part where you see the relevance. So look at this. Oh, I could expand this, yes. But you can't expand that. So we're going to do this using this, what we call the chain rule. All right, why the chain rule? It's like a chain reaction. Watch this. Let u equal to 3x plus 1, the stuff inside the square. Let u to be the stuff inside the square. And now y can be written as u squared. Y equal to u squared. So now we're going to write du dx, because u is in terms of x, which is 3, du dx. The other one is dy du, which is 2u. Again, pretty simple. Let u to be that complicated bit, and y becomes something simple. You can now differentiate both. That's what I do. Dy dx is same as dy du times du dx, and we just found them. What's dy du? This guy, 2u. What's du dx? This guy, 3. And then we simplify to be 6u. But remember, your final answer will be in terms of x. What was u again? 3x plus 1. And you will ask immediately, is that right? Is that the same as what we had before? Well, it's not exactly. It doesn't look the same. The one we had before was dy dx was 18x plus 6. But that's just exactly the expansion of that, which is that, right? So it actually works. So we can believe it actually works. So if that works, would it work for that? Yes, for sure. So I will do that again. So see how it works. We'll let you. It's like when we solve this equation, so to speak. Watch this. Remember the one we did earlier about this? I forgot, something like this. Like I forgot, something like that, right? So you just let u to be 2 to the power x, you get a quadratic, something like that. It's a very similar idea. We use substitution in calculus as well. It's the same idea, just used differently. Does that make sense? Okay, let's try the next one. So let's repeat the same step again. Let u to be the complicated bit, the inside. Right, u to be that, and y equal to u to the power 5. Yeah? And then you do the same thing. Now, quite right, u dash? No, because you look complicated. You should write du on dx. So that will know you're differentiating in respect to the right polynomial, x. And this one, you write y, dy, du, rather than y dash, because you get confused, right? Because if I write the formula dy over dx to be dy du times du dx, it will look awkward if you write y dash equal to y dash u dash, right? It just look wrong. That's dy dx, that's dy du. They're different. Hopefully that's clear. So again, not to use shortcut in this instance. So let's continue. Du dx. I'm going to ask student Priyanka, what's du dx? Okay, Joseph, next one. All right, u to the power 4. Well done. Substitute dy du, this guy there, 5 u to the power 4, du dx, 12x squared, and times things together, you get 60 x squared u to the power 4. But remember, you must replace the u by, in terms of x. So what was u again? U was this guy. Because you try to find dy dx, you just sit there like a stepping ladder, if that makes sense, right? So you just use it, and it's not really part of thing, right? Yeah. Like, all right, not recorded. You know what I mean? Okay, good. Should be 4. Sorry, I wrote the wrong 4. Sorry, I know. Sorry, got carried away. Yeah, but that's okay. You don't have to do that. But you get what I mean. But in maths, it doesn't involve pure person, so you won't upset the you. You can use it as many times as you want. You won't get upset. Okay. Now the next one is, so this is the statement of the chain rule. Why is it called the chain rule? Because you do it in chain, right? You do the dy du times du dx. 2 ways. There's another way to express it. So I'm going to show you, that's one way to do the question. I will show you a slightly faster way. I suggest you do it that way because I do it that way as well. Because like, it's almost like you try to cut off the middle person. Once you know how to do business, don't need the you. I could just do it myself, right? So let me show you. Watch this. Y equal to 3x plus 1 squared, right? Dy dx. Do it straight away. Watch. Pretend this is u. So if you pretend that's u, you got 2 bracket, no change in the inside, no change, right? And then differentiate this guy, 3. Do you get the same thing? Is that the same thing? 2u times 3, yeah? 2u times 3, but you just pretend there's no u. Pretend there's a u, yeah? Got it? Yes. I did a bit fast, but so basically differentiate the outside, then the inside, if that makes sense. So the chain reaction, differentiate the outside, then differentiate inside. How do I know it's the outside? Because when you do order of operation, you do the 3x plus 1 first and do the square last. So reverse. Let's differentiate the square first. So if I look at this structure, 3x plus 1 square, if I start with x, I have to times it by 3, then add 1, then square, right? So reverse. That's the outside. So you differentiate the square, then differentiate the 3x plus 1, if that makes sense, right? So if you can see the order operation, you will see how chain rule work. Your chain rule is that you reverse the order operation, you differentiate the outermost bracket first, then the inside. All right, we'll demonstrate that again. Okay, so let's try that again. So let's say, You can still do it that way. I mean, by all means, use that way. If you don't like this way, but I like shortcut. I'm sure you like shortcut. But if you prefer that way, if that helps you, that's fine. But after a while, you think, oh, I think I could do it without the U. Okay, do that. It's like when you ride a bicycle. When I was young, I need the extra two wheels at the back. But then after a while, I feel confident. Let's remove one wheel and then remove both wheels. I could do it, ride the bicycle. Yeah, that's what I did. Yeah, I taught myself how to ride bicycle. But I still can't swim. One day I will learn. Okay, watch this. Okay, how does it work? dy on dx equal 5 bracket. Remember, pretend that's a u, right? Again, what's inside does not change. Remember that. Does not change. Remain the same. Then differentiate this guy, which is 12x squared. Yes? Do you get the same answer? You do. 60x squared. So from now, I'll take the shortcut method. Yep. Okay, so how do I state the chain rule in a different way? I think that's the way they were stated in the formula sheet. So if you look at the chain rule on the reference sheet, oh, they do it that way. Okay, in the old reference sheet, they do it in the other way. Okay, that's good. Let me show you the other way. The other way you can express is y equal to f of u, right? Where you let u just, and then dy dx is f dash of u times du dx, right? So the f dash of u is actually this guy, dy du, right? So for example, if I demonstrate that to you, f of x was, in the previous question, was x to the power 5. If you do f dash of x, is 5 to the power x to the power 4. F dash with the u substituted, u was 4x cubed plus 2, right? So you substitute 4x cubed plus 2. If you don't understand all this, it's fine. But for those who's interested, you will see where the notation come from, right? That's f dash of u, right? So I don't know. Just want to see who likes the second method, the fast way. Yep. Who likes to let u be. So you like the fast way. So again, practice makes perfect. But again, how do I know which is to differentiate first? Use all the operations. Yeah. We'll do 3 more pages. Okay. Now before I do more questions, you may ask, how does it work in real life? I do actually have an example to illustrate to you, to try to get you to understand why is dy dx is same as dy du times du dx. If you look at the chain, actually that's a gear. Okay, so if you look at the gear, you will actually explain. All right, we can use the gear picture to illustrate the chain rule concept. If gear A turns once, see recording, that's good. Gear A still once. So when A turns once, how many times B turns? If you count the, how many times will B turn? How many turns? Look at the thing. 1, 2, 3. So if I start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 1, 2, 3, 4, 5, 6. So you have 3 times as many. What's that thing called? Is that called gear? The teeth. Yeah, 3 times as many teeth as this one. So if that thing turns once, if you sort of imagine your head, it will turn 3 times. Agree? So that means B turns 3 times as fast as A, right? So the bigger the gear, the slower they turn, right? If that makes sense. So the small one will turn 3 times as fast as A. If C turns once, gear B, that will twice as fast as B. So C must turn half as fast as B, if that makes sense. Okay, therefore, gear C turns. So how fast is C in respect to A then? Must be 1.5 times, right? Which is 3 times half, right? So how does that thing work? Well, if that thing is B turns 3 times as fast, now you can call B as the U. So U du dx is 3. This is C in respect to B. So you'd say dy du is half. And you can see C in respect to A, dy dx is same as dy du times du dx. So it actually works in real life. 3 times half, 1.5 times. So what you can say is, when you see that symbol, dy du dx, is how fast u. So when you look at du dx, what does it mean? It means how fast u changes in respect to x, right? That's the interpretation of du dx. And if you have the dy du is how fast y changes in respect to u. So whenever you see dy dx, another way to interpret that is how differentiate y in respect to x. So another way to say that is, when you see that, when you see du dx, means differentiate. So I will use this term use these terms very often. Differentiate u in respect to x. In respect to x. So instead of saying y dash, instead of saying the derivative, I will be more specific to say differentiate u in respect to x. Yeah. So it's more specifics, because sometimes when I say derivative, oh, just y dash, that's not specific enough because it depends on what polynomial you have. Okay, now we're going to do the question. So in the next 3 pages, we're going to do lots of differentiation. And when you get to uni, the lecturer will say, if you like differentiating, you will like that course, because a lot of courses, whether it's statistics, economics, or whatever, you'll find a lot of calculus. So that's a very good foundation when you study whatever you want to study at uni. Very good foundation. And people say you will enjoy this course because you just have to differentiate. And if you get yourself ready, it's going to be very easy. Okay, I'm going to use the shortcut method, dy dx. Remember, the outermost bracket is 6 something to power 5. First step. Yep. Right. Then differentiate the inside. Now, the easy question you get in the exam will just involve 2 steps. The outer bracket and the inside, right? And then you can have 3 layers. But that's just harder. You'll see some in the textbook. Do we do some of this? Maybe not. Not yet. But later on, you'll do more complicated ones. But now, I want to use I think it's faster if you just do it that way. Just easy. Helps you to think as well. Right? Got it? All right, let's try the next one. dy dx. I forgot to write y. So dy dx equal 7 times 5 to the power of 4, right? Whatever inside, do not change. And if you differentiate that guy, you get 3. Cool. All right, let's times this together. 3, 7 is 21. 21 times 5 is 105. Yep. Notice that I was very strategic. I do 7 times 3 first. It's easier to times by 5. Anyway, 105. Okay, so you like maths, you like, oh, calculus, love it. Once you know the rule, just apply the same rule every time. It's like try to do algebra again, but in a different context. So much easy, right? Have a try, and then we'll do some more. Okay, cool. Let's do another one. 7 bracket 3 minus 5x cubed, 6. And watch this. Differentiate that guy, you get negative 15x squared. Be careful the negative. 7 times 15. Oh, it's the same thing. See, that's good. So which one you times first makes a big difference. Oh, oops, sorry. That's good. Thank you. Everyone's awake. That's good. All right, excellent. And then we'll do another one where you have to do some analysis. Because he asked for, you don't have to sketch the curve. Find the points where the curve is tangent is horizontal. Let's try that. Okay, let's try this one. Differentiate y equal to, dy dx. Bring the 4 down. Pretty easy. 3. and then differentiate the inside, which is negative 4x cubed. Yep. 16, negative 16x cubed, 1 minus x power 4 cubed. Yep, like that. All good? Now that's done. Once we do that, the question goes further. They want you to find the point where the tangent is horizontal. What's that got to do with the derivative if the tangent is horizontal? What is equal to 0? Y equal to 0? Gradient, right? Because the tangent horizontal means gradient equal to 0. And that gradient is dy dx. Make that equal to 0. Okay, cool. Now it becomes an algebra, not derivative. So you've got to be good with algebra, and it's not that hard. When it's equal to 0, the factors must be equal to 0. So it's split into two. The negative 16x cubed is 0, or the 1 minus x power 4 cubed equal to 0. I should do both of these in a higher place. Watch this. Teleport. Can I teleport? Oh, watch. Teleport. Good. Okay, so I'm going to do it here. All right. So we go continue. Divide both sides by negative 16. You get 0 over negative 16. X cubed equal to 0. X equal to cube root of 0, which is 0. No problem. How about this one? Now, if it's cubed, oh, do I need to expand? The answer is no, because the right side is 0. You just cube root of 0. And root of any root of 0 is 0. So therefore, x power 4, I skip this step. X power 4 is 1. Hopefully you can see that. And then when it's an even power, it is always plus or minus. Even power. So plus or minus 1. I don't think I have enough space. Oops, sorry about that. Okay, so what you need to do to answer the question fully, you got to find the y value because they say points. So we've got the three values. X equal to 1, x equal to 0, x equal to negative 1. Find the y value. Right? And how do I find y? Use the original formula. This to get y. Okay, so what do we do? Put 1 in. 1 minus 1 to the power 4. To the power of 4, you get 0. Okay. Put 0 in. You get 1 minus 0 to the power 4. To the power 4, you get 1. I think the other one, you also get 0. So there are 3 points. 1, 0, 0, 1, negative 1, 0. Any question? Write it down. I'll give you a minute to adjust yourself. So write it down. Let's continue to start graphing. And does the calculus give you the right picture? It will give you the right picture. Desmos will support it. Experimentally verify this is the right thing. This is like good thing about maths. You can experimentally verify. You don't have to wait for someone else to do the experiment for you. To the power of, wrong, 4. Now remember what was the thing? 1, 0, 1, 0, negative 1, 0. These are the part where the tangent is horizontal. Right, Daddy? So it does give you a picture of the graph. Well done. That's good. Let's move on 2 more pages. So the chain rule are not, the application of chain rule are not limited to this differentiation. I could also differentiate parametric differentiation. Let's see how that works. Parametric differentiation. So we look at this, dx dt is 2. Okay, hang on, that's the wrong one. Method 2. Okay, now how do I find the Cartesian equation, hence find its derivative? Okay, so y x equal to 2t. Remember to find the Cartesian, make t the subject, substitute that into y. And you square that x squared equal to 4. Right? That's pretty easy. And once you get the Cartesian equation, you get dy over dx equal to 2x on 4. Nothing spectacular, right? Okay, so we'll just write this down. once we wrote this down, the question is, can we do it? Can we bypass the middle person? Can we just differentiate it without going to Cartesian form? The answer is yes. But how would the chain rule help us? Chain rule will help us a lot. Watch this. dy dx, instead of u, you use t, right? It's in terms of t. dy dt times dt dx, right? Oh, but what's the, but then you go like this, dy dt, you can write it like this, over, actually you can write that as dy dt divided by the reciprocal. So you get dy dt over dx dt. Would that work? So you just memorize that as a formula. dy dx can be written as dy dt over dx dt. And then what's dy dt? Well, you can just follow your nose. X equal to 2t, y equal to t squared. Dy dx is 2. Dy dt, sorry. Dy dt is 2. Dy dt is 2t. So you do 2t over 2. T. Is that right? But that's in terms of x. No problem. X is exactly, if you look at the question, or is it this bit, right? X is exactly, highlighted the wrong one, that's fine, just rub off. X equal to 2t, so therefore, x is 2t means t equal to x on 2. That's x on 2. Same as before. So it's good to know this skill, that you can differentiate parametric equations using chain rule. Powerful stuff. So chain rule stuff can, yeah. And then we're going to do a question on this. We'll do a question. And then we're going to answer a variety of questions about this. Okay. So there is a question. A curve is defined parametrically by this. Find the derivative at that point. So you do x equal t squared, y equal 2t, dx dt, dy dt. All right, work out and find dy dx. When they say derivative, they mean dy dx, not dy dt dx dt. That's just used to form the dy dx. So derivative is always dy dx, not these guys. Yeah. All right, dy dx is dy on dt over dx on dt. Sorry. Right. Okay. Dy dt is 2. Dx dt is 2t. Substitute and cancel to be 1 on t. Do I need to express that in terms of x? No, you don't need to. It's better to leave it in terms of t. All right, cool. Hopefully you're all done. Now we're going to find the equation of tangent. Well, the good news is the gradient is already found, because at t, the gradient of the tangent is already that. Right? And then we need the point. Well, the point is also given. The point t is the point, t squared 2t. That's your x1, y1. So therefore, I could just go y minus y1 equal to mx minus x1. So therefore, we're going to continue y minus 2t equal m x minus t squared. And then we're going to solve for, we're going to expand, make y the subject. So let's expand this. Expand, you get 1 on t, x, minus 1 on t times t squared is t. And then make y the subject. So y equal to 1 on t, x, minus t plus 2t. And that becomes y equal to 1 on t, x plus t. Done. All right, no problem. That's the equation of tangent at t. And they just follow the nose. See, maths, some people either find it very easy or they find it very hard. But if you just follow your nose, it's actually work. You'll work. Whereas in other subject, let's not comment. Let's only talk about maths. See, that's the thing. I just do app. All right, good. All right, x-intercept of A, intercept A of the tangent at t. So we got the tangent, and to find the x-intercept, you substitute y equal to 0. And you make t the subject. Oh, you make x the subject. You try to find x-intercept. So you get minus t equal to 1 on tx, x equal to negative t squared. Is that right? Yep, good. So the point A is negative t squared. That's your x-intercept, the point A. All right, cool. Yep, got it. Good. All right. After we do this, we'll find the midpoint. Again, follow your nose. Have we got A? Yes, we do. Have we got T? Just have to go back and write down what T was. And then find the midpoint. How easy is that? Seriously, follow your nose. It's that easy. It just uses your previous knowledge. So if you've forgotten about how to find midpoint, how to find x-intercept, you really need to revise, or you have to do something about it. We're just using the same thing. It's like different movie. They all are talking about the same thing. The hero always wins. Same thing, right? Same thing in maths. You just do the same thing again. All right, good. All right, what's that? So midpoint, negative t squared plus t squared on 2. 0 plus 2t on 2. Get cancelled 0 comma t. That's it, done. Oh, and then say, why does m lies on the y-axis? Why is that on the y-axis? Why? That's it. The x-coordinate is 0. Therefore, m lies on the y-axis. Yeah, the 0 tells you it's on the y-axis. All right, cool. Okay, now you may ask, what's the Cartesian equation of t? The Cartesian equation is x equal to t squared, y equal to 2t. It is a sideways parabola, so you make t the subject and substitute. X equal to y on 2 square, you get y squared over 4, y squared equal to 4x. All right, that's it. That's all you have to do. Unfortunately, we've got one more page. I know it's getting a bit boring, but that's the last thing we'll do today. And tomorrow, next lesson, you got Wednesday to finish the homework. That's good. Okay, we've got one more page, then we're done. This one's a little bit quicker. I'll put this up a bit. Sorry if I went too fast. Okay. Go to the next page. So you can apply chain rule to parametric differentiation as well as inverse functions. So it has a lot of applications. So everything now starts to connect into a big, nice picture that's all consistent. How is it related? Okay, if you watch it, you will see it, you understand. So let's revise what's the inverse function. Y equal to x squared, swap x and y, right? So you get x equal to y squared, make y the subject, you get that. Now, I say, is it a plus or minus? Now, we'll just take the positive, just to demonstrate. Okay. So that's your function. That's your inverse function. Right? The square root is an inverse function of x squared. All right, we just demonstrated that, right? That's the inverse. Derivative of inverse. Oh, that's pretty straightforward. I just have to use that rule, if you still remember. F of x is root x. Now, that rule also works for fraction, but you're not meant to do it that way. I'm going to show you a different way to do that. Right? F of x, right? So f dash of x equal to half x power negative half. And then you get half 1 on x power half, which is 1 on 2 root x. Okay, we just have to remember that. Now I'm going to show you a different way. Now, we're not meant to do this. We're meant to do this sort of fractional stuff in 9G. But just there for you to see that this formula works for an inverse function. So you can differentiate the inverse function without actually finding the inverse. And I could show you how to do that. And this again due to the rule. dy dx is that. It's not the reciprocal, it's due to the chain rule. Why is it due to the chain rule? Because dy dx is same as, well, if you do it that way, dx dy, they're equal to 1, right? And then what do? It's just reciprocal, 1 divided by dx dy. So that's where that rule comes from. Yep. Okay. So why is that relevant to inverse? Okay, I'll show you exactly why it's relevant. So what you do is, so remember, y equal to x squared, the inverse was y squared over x, right? That's the inverse. We swap x and y, not making y the subject. And then what you do is this. Since x is the subject, let's do dx dy, right? Dx dy is 2y, right? Dx dy is 2y. So instead of doing dy dx, I do dx dy, y do the inverse. And we know that, and therefore, to find the dy dx, I just have to reciprocal the dx dy. And to reciprocal dx dy, just go 2y. That's it, 2y. Yep. And what's y? Y was just, if you look at that one, y was just root x. Bingo. Oh, get the same thing. Because we're not meant to use that rule yet, because we're not meant to use the fractional index yet. So can you see it works? Yeah? Yeah, but you wouldn't do it that way. You would just use that quick rule. I will use that rule. But it's just there to show you that you can use it for inverse. And if the question becomes more complicated, that becomes more important. But now you don't see the relevance because it doesn't cut off that many works. But you will make an important difference when we do the inverse trigonometric functions, which we'll discuss in chapter 17. Actually, not 17. They won't be differentiating it, will they? I forgot. Maybe next year. All right, cool. I've got one more comment about the chain rule. Now, if I look at this, what's the derivative? Any questions? Who knows it? Joseph? Samuel? Derivative of that? No. Wouldn't that be 0, right? It's a number. But you're right. You're right. 3 times something. Watch this. Let u equal to 4, right? But then would it be crazy? Like you get u to the power cube. Oh, yes. Let's dy du is 3u. But what happens when you do du dx? You get what? 0, right? So if you do dy dx, dy du dx, you get 3u squared times 0. So you still get 0, right? Does that make sense? So the chain rule still makes sense. You think, oh, why create something new? No, it's still 0. Get the idea? Yeah? Yeah, if you use the chain rule. So the chain rule will actually work. Okay, cool. All right, so today you'll do, it is one of the most important. So if you struggle with that, you'll struggle later. We're going to use chain rule in a lot of situations. There's still 40 minutes left. Please use the time wisely. Minimize the talk. You will see a difference. Yep, got it. Thank you. All right, start now.